Hello, today we look at this integral and we are going to be looking at three different ways of approaching it. We have integral from 0 to pi over 6 of cos x sin x dx. In the first method, we are going to be simplifying the integrand using the double angle identity. Sin 2 theta equals 2 sin theta cos theta. So we have the integral, which is from 0 to pi on 6 of sin x cos x. Since the integrand is the product of two trigonometric functions, sine and cosine, we can make use of the double angle identity sin 2 theta equals 2 sin theta cos theta and express the integrand as a single trigonometric function, which will now give us the ease with which we can integrate the function. So in order to bring in the identity, I have to multiply by 2 and divide by 2. When I multiply by 2, I can then have 2 sin x cos x, which will give sin 2x. This half would stay out of the integral, as it is what was used to modify the function to obtain the identity. Generally, the integral of sin x is negative cos x. But since this is the sign of a linear function of x, we have to integrate and divide by the differential of that linear function. The differential of 2x being 2, we can then see that the integral will be negative half cos 2x. And in the next step, we proceed to substitute the limits, the upper limit being pi on 6 and the lower limit being 0. We have that half times negative half would give negative 1/4, and substituting the upper limit, we have negative 1/4 cos 2 pi on 6 minus negative 1/4 cos 0, 0 being the lower limit. In the next step, we simplify further negative 1/4 into half, half being the cosine of pi on 3, because 2 pi on 6 gives pi on 3, and pi on 3 converted from radians to degrees gives 60 degrees. The cosine of 60 degrees is half. Negative times negative gives positive, and then we have 1/4 times the cosine of 0, which is 1. So at the end we get negative 1 over 8 plus 1/4, which indicates then that the integral from 0 to pi on 6 of sin x cos x dx is 1 all over 8. In the second method, we would do substitution. We look at the function again, which is given as integral from 0 to pi on 6 of sin x cos x. We would notice that it is the product of two functions, and one of them is the exact differential of the other. So we can do a substitution of the function that has been differentiated to get the other function. So we can let u to be sin x, because the differential of sin x gives cos x, although it is still possible to also let u to be cos x in this case. So if u equals sin x, then differentiating with respect to x, we see that du would be equal to cos x dx. Then we also need to change the limits to reflect the new variable, and when x equals 0, we have that u should be sin 0, which is 0, and when x equals pi on 6, u equals sin pi on 6, pi on 6 being 30 degrees, sin 30 is half. So we have that integral from 0 to pi on 6 of sin x cos x dx simply becomes integral from 0 to half of u du, because sin x is u and cos x dx is du. If we integrate u, we have that u squared, which is simply u to the 1 plus 1 all over 1 plus 1, and it gives u squared over 2. And we have to substitute the limits from 0 to half. Substituting, we have half into half squared minus the substitution of 0, which gives 0. Again, it gives 1 all over 8. And so in this method, the integral is still 1 over 8. In the last method, we're going to use integration by parts, and the formula for integration by parts is that if we have the integral of a product of two functions, it might be possible for us to consider one of the functions as u and the other one as dv dx. The function that is easy to differentiate should be the u, while the function that is easy to integrate should be the dv dx. And integrating that function with respect to x, the formula says we multiply u by v, then subtract the integral of v du dx, and then dx. And this comes actually from the product rule of differentiation. So bringing our integral, we can then consider sine x as the u and cos x as the dv dx, or vice versa, because it will still work in both cases. If we let u to be sine x, then du dx should be cos x, and further, if we let dv dx to be cos x, then v should be the integral of cos x dx, which gives sine x. Bringing the formula, then we can substitute. Since the formula says uv, the u is sine x and the v is also sine x, so sine x times sine x, and substituting the limits from 0 to pi on 6 minus the integral from 0 to pi on 6 of v du dx, and v is sine x while du dx is cos x dx. In this step, we note that this other part of the solution gives the integral that we are seeking to find, so we can send it to the left hand side and it would add to the one that is there. So in the next step, sending this term to the left hand side, it would add to the identical one that is there to give twice the integral from 0 to pi on 6 of sine x cos x dx, which we can now simplify by substituting the limits of the integral, which were from 0 to pi on 6. Sine x times sine x was simplified to sine squared x. Substituting the upper limit, we have sine squared of pi on 6 minus substitution of the lower limit, which is sine squared of 0. And in the next step, we can then see that the substitution of pi on 6, so sine pi on 6 is half, and the square of half minus sine 0, which is 0, and 0 squared would still give 0. So overall, half into the square of half still gives 1 over 8, which is the same value we had for the other two methods. Thanks for watching, and see you in the next video.